Here is a concept map that I've crafted as a way to represent and summarize the key concepts and their relationships to one another from this week's chapter. As suggested in the previous concept mapping, this concept map will not be unlike the previous one, that is, addressing hypothesis testing, but this time we'll be doing hypothesis testing with two means. This particular test, as promised in the last concept mapping, has the same logical structure. You can think of it in terms of 6 steps. We begin with formulating a null hypothesis. We then move on to step 2, setting a level of significance. Step 3, identifying a critical value. The 4th step, calculating a test statistic. Moving from there on to step 5, we have evaluating the test statistic in light of the critical region or region of rejection. And the final step, making a decision about the null hypothesis. The meat of this test, or the bulk of it, falls under calculating a test statistic. But before we look at that step, let's return to the first step, formulating a null hypothesis. In this case, our H0, that is our research statement, is written in one of 2 ways. H0 is there is no difference between the means, or we can write it as mu1 minus mu2 is equal to 0, where mu1 represents the mean of the first population and mu2 represents the mean of the second population. As noted previously, we have to set the level of significance. This must be done in advance. It must be determined by the researcher, i.e. you. In terms of identifying a critical value, this requires the use of the t-distribution table. And whenever we use that table, we need to know the degrees of freedom and the level of significance to determine our t-values. This brings us to the core of our test, and is determined by whether or not we are looking at a difference which is a mean difference or is a difference of means. In the case where the difference is a mean difference, we are looking at samples that are related, matched, or paired. Or in other words, the cases for one sample are not selected independently of the other. In the event that the difference is a difference of means, we are looking at samples that are said to be independent of one another. In other words, no case from one sample is related to any case in the other sample. So let's look at the case where the samples are related, matched, or paired. In other words, we're looking at a mean difference. In other words, we need to know a few things now. We need to know the average sample difference between related cases. And this is determined by a particular formula. Big D bar is equal to the sum of all the differences divided by the number of samples in each sample. We also need to calculate the standard deviation of the sample differences. This too is determined by a formula. The standard deviation for the differences is equal to the square root of the sum of the square of the deviations. I'll stop there. But do take note of the formula. It's getting a little messy. Please don't try to memorize these formulas, but I do ask that you take some time to attempt to understand what they mean. Once we've calculated the standard deviation of the sample differences, we need it to calculate the estimate of the standard error of the mean differences. And lo and behold, this also is provided through a formula, which begins S sub D bar equals, and so on and so forth. Once we have the formulas for D bar, that is the average sample difference between related cases, as well as the estimate of the standard error of the mean differences, or S D bar, we use these two values to calculate the t